Hey hackers, I'm Kailash Parshad from HackProKP, and in this video we'll talk about HTTP protocol, that is Hypertext Transfer Protocol. So without any further ado, let us start with the video. What is HTTP? HTTP, which stands for Hypertext Transfer Protocol, is the foundation of data communication on the World Wide Web. It's an application layer protocol used for transmitting hypermedia documents such as HTML. HTTP is the protocol used by web browsers and servers to communicate over the internet. HTTP is implemented in two programs, a client program and a server program. The client program and the server program, executing on different end systems, talk to each other by exchanging HTTP messages. HTTP defines the structure of these messages and how the client and server exchange the messages. Now we will talk about client and servers. Client. It is typically the web browser or any other application that initiates a request to the server. Server. This is a computer or a system that responds to requests from the clients. It hosts resources such as web pages, images, or other content. Now we will see a small visualization. You can see that web client 1 is going to initiate or send an HTTP request to the server, and the server is going to reply with an HTTP response. Now we will talk more about this request and response cycle. The communication between the client and the server happens in a request-response cycle, means the computer is going to request some resources and the server is going to provide them. There is a possibility that the error message is also given as the response, because for example, if a file is not there, then we are going to get an error of 404 not found. We will talk more about this later in this video. Let's take a look at HTTP methods or verbs. HTTP defines several methods that indicate the desired action to be performed on a resource. Some of the common methods include get, post, put, delete, head. Get, as the name suggests, retrieves data from the server. Post is used when we want to submit some data to the server, like for example, use a credential for authentication. Put updates a resource or creates a new resource if it doesn't exist. As the name suggests, we are going to put some files on the server. Delete request of removal of a resource. Head retrieves only the headers of the resource without the actual data. Now let us talk more about the get request. Get request, as we have talked before, is used to retrieve data from the server. Parameters are included in the URL. As you guys can see that we are using get protocol to retrieve some data from the server, and we are also passing the parameters, that is param1 and param2, to the server. And in the right we can see the HTTP version. Now we will talk about post method. Post method is used to submit data to the server to be processed for a specific field. For example, as I told you before, authentication. That is, we are submitting our username and password to the server to validate and check if we are the person that we are claiming to be. The parameters that we are going to submit are going to be in the request body and not in the URL. In the example, we can see that we are using the post method to submit something to the form, and we are able to see the HTTP version, that is 1.1. We can see that the content type is www form URL encoded. This means that the data is going to be URL encoded, and we are sending the parameters as well in the request body. Now we'll talk about put method in the HTTP verbs or methods. We can use put to update a resource or create a new resource if it doesn't exist on the server. This method is similar to the post method, but it is typically used for updating existing resources. Example of this could be put update resources. So we are updating the files, the resource file with some JSON values. How do I know the content type? Because we are also mentioning that in the request body. Now we are going to talk about the delete method in the HTTP methods. As the name suggests, delete is used to delete a specific file or resource from the server. Often requires additional authentication for security, because if everybody can delete anything, that there is a possibility that the hackers try to delete the login credentials checker PHP file, for example. The example of this method can be seen down below, that is delete. We are specifying the resource that we want to delete and the HTTP version. Now we'll talk about head protocol in the HTTP methods. Head, as the name suggests, is similar to get but only retrieves the headers and not the actual data. This method is often used while debugging something because we can check if some resources have been modified without actually downloading the entire content from the web and saving some bandwidth. Example we can see in the bottom head, we are mentioning the resource and the HTTP version. Now we are going to talk about URL, that is Uniform Resource Locator. URLs are often to identify and locate resources on the web. They consist of a protocol, example HTTP or HTTPS, a domain name and a path to the resource on the server. Now let us check out an example of an URL. So we can see in the beginning the protocol mentioned and the domain name afterwards, the path of the resource and the parameters or queries that we are sending to the server. Protocol specifies the protocol used, example HTTP or HTTPS. Domain/host identifies the server. Path specifies the location of the resource on the server. Query parameters additional data sent to the server. Now we are going to talk about headers. Both request and response include headers, which provide additional information about the request or the response. Headers can include details like content type, length, caching, derivatives, etc. Now we are going to see some headers that are common in request and responses. First, we are going to start with request. Host specifies the domain name of the server. User agent identifies the clients making the request. Content type specifies the type of data in the request body. Now common response types. Content type specifies the type of data in the response body. Status code indicates the result of the request. Now we're going to see an actual HTTP request. On the right hand side, you're able to see an HTTP request made to google.com searching for what is HTTP. Now this request is intercepted through Burp Suite. We are going to talk about Burp Suite in later videos, but we are able to see what all resource data has been sent to google.com for searching this. Now we'll see the response for this request. We are able to see that we got 200 OK status code, that means it was found, and we are able to see the data contents that was sent by google.com to us. Now let us talk more about status codes, because status codes are very important when we are dealing with web penetration testing. Status code indicates the result of the HTTP request. Now let's talk more about the categories. In the response, if you got a status code in the range of 100, this means that this is informational. If it was in the range of 200s, then it was a success rate or it was found on the server. If it was in the 300 rates, then this means redirection. If it was 400 range, this means client error. If it was in the 500 range, then this is a server error. Now we will see an example of an HTTP 200 status code. 200 OK status code means that the request was successful. 404 not found means that the requested resource could not be found. 500 internal server error means something went wrong on the server side. Now we will see a different version of the HTTP protocol. HTTP 1.1 and HTTP 2 are common versions used today. HTTP 2 introduces improvements in performance and efficiency over HTTP 1.1. HTTP 1.1 is widely used, but HTTP 2 introduces improvements in the performance and efficiency, allowing multiple requests to be multiplexed over a single connection. This is a big deal when we compare this to HTTP 1.1. Now we will talk about statelessness. HTTP is a stateless protocol, meaning each request from the client to the server is independent, and the server doesn't retain information about the client between requests. Sessions and cookies are often used to maintain the state. Now we are going to talk about HTTP protocol with security. That is going to be HTTPS, Hypertext Transfer Protocol Secure. HTTPS is a secure version of the HTTP protocol that encrypts the data exchanged between the client and the server, providing a more secure communication channel. HTTPS encrypts the data exchange between the client and the server by using TLS, that is Transport Layer Security, providing a secure communication channel. We are going to learn more about TLS in the next video, that is going to be about HTTPS. Coming back to our topic, we are going to discuss WebSockets now. So guys, HTTP is traditionally request response based. WebSockets provide full duplex communication. So WebSocket is going to create a communication channel over a single long-lived connection, which is going to allow full duplex communication between the client and the server. Full duplex communication means that the communication is bidirectional. Now we are going to talk about authentication in HTTP protocol. For HTTP protocol supports various authentication mechanisms. such as basic authentication or OAuth. This is very important for secure access of data and resources. Now let us start with the lab component for today's video. I want you guys to go to my GitHub repository and download the PKT file, that is Cisco Packet Tracer file, for this video. For your convenience, I will provide the direct download link in the video description. The step remains the same. After this, you have to click on download raw file. After the file is completed, you have to just open the file with Cisco Packet Tracer. That is as simple as double clicking on the file. When the Cisco Packet Tracer has been completely opened, I want you to click on the fast forward button on the lower left hand side. We are doing this so that we don't really have to wait for the actual devices to boot, because Cisco Packet Tracer also replicates booting of devices. We can see that there are different computers, that is PCs, laptops are there. We have routers, switches and all, and we are able to make a small internet environment in this Cisco Packet Tracer file. So as you guys can see, we have servers like Outlook, MSN, DNS, and we are able to see the actual IP addresses and all. And in the services part, we are able to see that they are hosting some files and HTTP is enabled. So if we open to the edit part of this, we are able to see the HTTP file. Now let us close this and open the MSN server. Now for the MSN server as well, this is going to be the same. It is also hosting an HTTP web server, and it has all the files that are needed. Now let's move on to the PC, for example. So I want you to open the PC, and in the PC I want you to go to the desktop part, not the programming. One second. In the desktop part, I want you to open web browser. Now the web browser can take some time to open, so please be patient. Now I want you guys to write www.msn.com. One second, we should write HTTP as well, so that we can mention the protocol that we are using. So you guys can see that I have mentioned HTTP. Now we're going to press go button. Now this is going to take some time, so please be patient. We are able to see the MSN website. Now this is not the actual website, but you get the idea. Now we are going to go in the simulation part. Now in simulation part, we can control each packet. So we are going to open the web browser again. We are going to write http://www.msn.com and click the go button. You will see a packet has been generated on PC1. If we click this packet, we are able to see that this is a DNS request packet, and specifically it is an ADNS request. What is ADNS request? We are going to learn more about this in the later videos. We are going to skip this part. So what is happening in the backend side right now is we are asking the DNS server for the IP address of the msn.com server. Now we can see that this has been received, and ADNS response we have been received. And if we go in the inbound PDU details, we are able to see the actual DNS query that we have sent to the DNS server and the actual DNS answer right here. So we are able to see the IP address of msn.com. So now we are going to send in TCP packet, because before HTTP packets can be sent, we have to make an TCP three-way handshake. So let's start doing this. Clicking on the forward button, and we are able to see the packet is moving in real time. Not in real time, but we are able to control the packet and the flow of the packets. And right now it has been received by the client. If we open this, we are able to see that this was completed, and we were able to receive an SYNAC from the server. Now we are going to send an ACK TCP packet, and with that ACK packet we are going to send the HTTP request packet as well, requesting for the website. If we open this HTTP protocol packet, and we can see that we are trying to get some information from the HTTP client, and in the HTTP request we are able to see the actual request that we are sending to the server. Now clicking on the forward button, we can see that the TCP connection was completed, and the server received the HTTP request as well. So the HTTP response is coming back to us. and it has been received. Now if you guys will see or open this packet, you will see the response as well in the inbound PDU details. So we are able to see the response as well. So this means if you open the web browser, one second, so we are able to see the website is there. Now I want you guys to play with this file and open other websites from your personal PC web browser, and make sure that you're giving some time for this to load, because there's a possibility that it is slow on some computers. Alright hackers, that's a wrap for today's session. If you found value on this video, leave a like, share it with your fellow hackers, and comment below your thoughts. Don't forget to subscribe for more content that will propel your hacking journey to new heights. Thank you for joining me today on HackProKP. I'm Kailash Parshad, and until next time, happy hacking.